Okay, you guys, this is our first physics unit. So you will need a calculator for this unit. So if you have a calculator in your backpack, go ahead and take it out. If you need to borrow a calculator from my classroom, they're in the yellow container up front. Make sure that you get them turned back in. I have a limited amount, so if you take them home, they won't be there next time you need one. Okay, so our essential question today is, what is the difference between distance and displacement? So we've got two science words in there. Let's go ahead and highlight them. Distance and displacement. And we want to know kind of what is the difference between those two things. So I always think the best way to find differences is to define both of those things. So that is what we're going to do to start here. So this whole unit that we're going to be doing is about motion and movement. And ultimately, we need to kind of decide, like, how do you know that something is moving? And so in order to decide if something is moving, we use something called a reference point. So a reference point is a point or an object that doesn't move. So we know from experience that it is something that definitely doesn't move on its own. And so we can use it to compare movement of other things. So if we look at the picture below, this is at 9 a.m. and the second picture is at 9:01 a.m., a minute later. And this is kind of one of those, like, what's different about the two pictures? The major difference I see is that the postal truck, which is here at 9 o'clock, has moved to down here at 9:01. So there's kind of two options. Maybe the picture was taken from a different place, so maybe the truck really didn't move, or maybe the truck has moved. So in order to decide if there was motion, if that truck moved, we need to choose a reference point. And again, we want to choose something that doesn't move. So I am going to look at this tree. Let me grab a different color here. This tree here. Okay, so trees are planted in the ground. They can't walk away on their own. And when I look at both pictures, my tree is in the same spot, which means that in reference to the tree, the truck has moved. Okay, another thing that I could look at is this little fire hydrant here. So here is a fire hydrant, and in the other picture, it's in the same spot in the picture, but in picture number 1, the truck was before the fire hydrant, and in picture number 2, the truck is after the fire hydrant. Okay. Another reference we could choose is a house. A house just can't get up and move on its own. And so in these two pictures, the houses are in the same location, that white house there. But compared to it, the truck is in a different spot. So in the first picture here, the truck is way before that house. And then in the second picture, it looks like it's kind of across the street from that house. So again, you guys, you're going to decide if something has moved based off of something that can't move. Okay, because remember, there was kind of two scenarios there. Did the truck really move, or did the camera person move? And we decided the truck moved because we were able to find at least 3 reference points in the picture that showed us that, in fact, the vehicle had moved and not those other objects. Okay, so one thing that we need to know about reference points, or those objects that we choose, is that you have to choose something that doesn't move, and everyone's frame of reference is different. So if you chose the house and someone else chose the tree, that doesn't mean that someone else is wrong. It just means that you're looking at the picture in a different way. And it's good to have different people's experiences. Okay, so pause the video and answer these checkpoint questions. How do you know something is moving? And then pick a frame of reference for each of the following situations in a car. So when you pick a frame of reference, you're picking something that you could use to compare how the object is moving. Okay, so go ahead and pause the video. Okay, hopefully you actually pause the video. So how do you know something is moving? You choose a reference point. and then you compare over time the position of the object over time. Okay. And then number 2, pick a frame of reference. So if I want to know how fast a car is moving, and I am standing on the sidewalk, I might look at like a street light and see how fast it's coming. Or maybe I would look at a tree, or maybe even other cars to see is it going faster than other cars or slower than other cars. And then if I want to know how fast a ball is being thrown from the front seat to the back seat. So now I'm in the car. So I probably don't want to choose something that's outside the car because I'm assuming we're probably driving. And so it's not going to be helpful if I look at the trees zooming by. That's not going to tell me how fast the ball is inside the car. So I'm going to look at the ball compared to, maybe I'm in the back seat, the front seat. Or compared to my window. So how fast is it moving past my window on the inside? Okay, so someone from the maybe front is throwing it all the way to the back seat, maybe my third row seating, and I want to know, when do I put my hands up so that it doesn't hit me? Okay, so once we know that something is moving, now we can measure its motion in different ways. So the first way that we're going to measure motion is with distance. Okay, for each of these we want a definition, and then we also want the units. Remember, anytime we make a measurement or do a calculation, the units are super important. Okay, so distance is a total measurement of how far something has gone. So there's kind of 2 key words in here. First is total. So when I think total, I'm thinking all the parts. Okay, and then how far something has gone. So if I go on a bike ride, I'm going to add up kind of all the places I went, and that's going to be my total distance. Units for these are going to be things like millimeters, centimeters, meters, kilometers. My base in this is meter. And remember from our first unit a long time ago, meters is a measurement of distance. The second way that we can measure motion is with displacement. And displacement is slightly different. So displacement is not the total distance, it's the shortest distance from start to end with direction. The units for this are the same, but they also include a direction. So this compass here is something you will need to memorize. So north is up, south is down, and then we've got west and east. So west is going to be to your left and east is to your right. When you look at the compass, it's we across. Okay. And then if you are kind of partially in between, it would be a combination of those things. So north and south always come first, and then the side-to-side direction comes second. We're going to have this compass for you for quizzes, but ultimately on test day, you'll have to have that memorized. Okay, so let's look at how this is different. Let's actually do one of these. So when we do these, we are going to draw pictures or diagrams. So we're going to read a scenario. We're going to pull out the important information, and then we're going to do some calculations. So these have a couple of different pieces. So first, we draw a picture. When we draw a picture, you need to have a starting point. And I am always going to provide you with graph paper so that you can be really exact in your drawings. And I usually like to start in the middle of the paper. You'll kind of get a feel for where you need to be as you do more practice. So on this one here, my start is right here. And again, I put it at kind of a little corner spot, and I put S for start. You're going to get points for that. Okay. Next, you are going to go through the scenario and draw the scenario out. So in this case, we're going to draw each segment to scale. So in this, I went start, and then I went south. I went down 6 miles. So I went 1, 2, 3, 4, 5, 6 boxes down. And then notice there's not like a blank spot. I kept going. I went to the west 7 miles. 1, 2, 3, 4, 5, 6, 7. And I'm being really careful to use my boxes so that it's all to scale, meaning that when we compare, we can use this drawing to compare. We won't have to do any math with it. Next, we are going to go up north 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we are going to go east 7. 1, 2, 3, 4, 5, 6, 7. And then a really important thing is when you are done with the last step, you are going to label the end point. So I'm just going to put a dot for the end and then label it E for end. Okay, so in our drawing, there's going to be 3 points. 3 points possible. So one is going to be that you labeled your start and end with an S and an E. Super important for calculations. The second point is going to be that the drawing is done accurately. So did you follow the directions in the problem? And then the third point will be, did you label it? So these things, the 6 miles, 7 miles, 10 miles, and 7 miles, those are my labels for each segment. And segments are just kind of the parts of the graph or parts of the drawing. Next, we're going to be able to calculate a distance. So when we calculate a distance, we're going to add the distance of each segment together. So for this one, first we went 6, then we went 7, then we went 10, and fourth we went 7 more. So when I add those together, I end up getting 30 with the unit miles. You cannot abbreviate miles with an M because that's meters, so be careful. Okay, so my distance is 30 miles. Again, distance is a total, so I did all of that. The displacement is the shortest distance from start to end. So to find that, I'm going to draw a straight line from start to end. Okay, so I'm going to connect my start and my end box. Okay, my start and my end dots are connected. This piece, this right here, is my displacement. If it's a straight line in the boxes, meaning it goes with the boxes, not across the boxes, I can just count the boxes. So I'm going to count up 1, 2, 3, 4. So in this, my displacement is 4 boxes, and each box is a mile, so it's 4 miles. I need to also include a direction, and it's going to go from start up to end, which is north. So it's 4 miles north. If this ended up being a diagonal line, so if it went like this across my graph, my boxes don't work to count that way, and so I'm going to have to do a little math. I'm going to have to use the Pythagorean theorem, which is a squared plus b squared equals c squared, and use a triangle. We'll practice one of those as well. Okay, so let's try one of these. So first thing we need to do is get our scenario drawn. So we're going to choose a starting point. So I'm going to choose kind of the middle of my graph and label that S for start. Next, I'm going to follow my scenario. So it says I travel 1 kilometer north and 6 kilometers south. So I'm going to have 2 parts to my line. So first, I'm going to go 1 kilometer north, which is up. And then don't pick up your pencil, okay? I'm going to go 6 kilometers south from right here. So I'm going to go back down my line. So I'm going to change the color so you can see that. I'm going to go 1, 2, 3, 4, 5, 6. Before I pick my pencil up on that last direction, I'm going to label it E for end. Okay, so I've got my start, I've got my end, I have my accurate drawing, I need to do my labels. So this first piece that I did was 1 kilometer. And then from the top all the way down to the bottom, this was my 6 kilometers. Okay, here we go. What is your total distance? So to find a total, we're going to add. So first I went 1 kilometer, and then I went 6 kilometers for a total of 7 kilometers. And notice, you guys, I always box my answers in so that I can find them easily, and when I'm grading, that helps me. So if you could box your final answer in, that'd be awesome. Next is going to be your total displacement. And remember, displacement is from start to end, which is why it's so important for you to have the start and end labels. So I'm going to put my pencil on my start, and I'm going to connect it to my end, and I'm going to put that arrow in there to show my direction. So if it follows either the vertical up and down or the horizontal across, I can just count my boxes because I know that I did a good job with my drawing. So I'm going to count 1, 2, 3, 4, 5 boxes, which is 5 kilometers. And then my direction, my arrow points down, so that means it's south. Okay, so I drew my picture, I calculated my distance, and then I calculated my displacement. These problems are worth a lot of points because we're looking for specific things in your drawing. We're looking for you to always show your work in your calculations. And then there are units that you need to include. And displacement has 2 units, the measurement and the direction. So just be really careful with that, you guys. Kind of go through your checklist. Okay, let's try one more together, and then I'm going to have you guys try some on your own. This is a longer scenario. Okay, so I'm going to choose my starting point. Again, just kind of choose it in the middle here. And then I'm going 2 kilometers north, 4 kilometers east, 4 kilometers south, and 6 kilometers west. So I'm going to have 4 segments or 4 parts to my scenario. I'm going to use different colors just to make this a little bit easier. So let's start. I'm going to go from my start, and I'm going to go 2 kilometers north. So I'm going to go up 2. Now don't pick up your pencil in between, okay? I'm going to go 4 kilometers east. 1, 2, 3, 4. Don't pick up your pencil. I'm going to go 4 kilometers south. 1, 2, 3, 4. And then I'm going to go 6 kilometers west. Again, don't pick up your pencil till the very end. 1, 2, 3, 4, 5, 6. Now this is my last one. So I'm going to draw a dot, and I'm going to label it E for end. Okay, so I've got my start and my end labeled. I have the correct drawing. Now I need to label each segment. So first I did 2 kilometers, and then I did 4 kilometers, 4 kilometers, and 6 kilometers. Okay, and this is a good time for me to check that my drawing was correct when I add those values in. Does it match my scenario? Okay, so first is a total distance. So I'm going to add together all the pieces. So I went 2, and then 4, and then another 4, and 6. So 2 plus 4 is 6, plus 4 is 10, plus 6 is 16. And then my unit, kilometers. Feel free to use a calculator, you guys. I don't want your mistake to be in the math, so use your calculator. Next, we're doing displacement, and displacement is start to end. So I'm going to go on my drawing, and I'm going to put a dot on the start, and I'm going to connect it in a straight line to my end. And what I see is this is not horizontal or vertical. This is diagonal. So this is going to be a little bit different. So when I have that diagonal, I'm going to use a squared plus b squared equals c squared. This is for a triangle. So I need to make a triangle. So I'm going to close the sides and make a triangle here. Okay, so I'm focusing on that little black triangle. When we're looking at Pythagorean theorem, the a squared plus b squared equals c squared, a is a leg, so that's going to be a vertical or horizontal, up or down, or up or sideways. B is the other leg, and C is the diagonal. C is what we're looking for. So ultimately, I want to know what is C. What is the diagonal? That's my displacement in this case. Okay. So it doesn't matter which leg you choose for A and B. So I'm going to just say my up leg is A. So in this case, it's 2 boxes. So I'm going to say 2 squared. And then I'm going to say my horizontal or my cross leg is B. So that is also 2 boxes. And then I don't know what C is. That's what I'm trying to find. Okay. Now I'm going to start doing some math. So 2 squared is the same as 2 times 2. So that's 4. And 2 squared, again, same as 2 times 2, that's 4. And I still don't know anything about C, so I'm just carrying that unknown piece all the way down to the end. Okay, keep doing math. 4 plus 4 is 8. And again, I still don't know that C squared, so I'm just bringing it down. But I don't want C squared, I just want C. So how do you undo a squared? To undo a squared, we're going to take the square root. So on your calculators, the square root is the key that looks like this. So on the calculators in my classroom, you are going to type the number first. So I would type in the number 8. And then you're going to do the square root key, and it will give you your answer. Some calculators, you have to do the square root key first and then push 8. So we'll have to kind of learn how to use our calculators. So when I take the square root of 8, I get 2.828427125. Never write all of those numbers, okay? We're gonna probably take like 2 decimals. So if my calculator tells me 2.828427125, oh, that's a horrible number. I'm going to go over 2 decimals. So the number I want to round is this 2 right here. So since there's an 8 after it, I'm going to round that up. So C equals 2.83. It's only half of it though. I need a unit. So all my measurements were kilometers. And I need a direction. So from start, and then I'm drawing arrows to the end. So it's going down, which is south, but it's not going straight down. It's going down and to the left, which is southwest. Okay, so those ones are a little bit more involved. For your homework, you guys, you are going to try 6 of these on the assignment. Okay, so for tomorrow, please come with those 6 problems. You should draw the picture, calculate the distance, and if you get stuck on the displacement, get as far as you can so that you can ask a specific question.